Hi, in this video, I'm discussing a question related to hydrostatics of fluids, and the question is shown on the screen. Okay, so this question is related to upthrust, Archimedes principle. We need to use, a part of the rod is inside the liquid, so there will be upthrust. So we should know the upthrust is equal to, according to Archimedes principle, upthrust is equal to weight of the displaced fluid. And very important, you must know where will it act. Normally that's a confusion. Students, they ask, where will it at the upthrust? Where should we mark the upthrust? Actually, upthrust will act on the center of mass or center of gravity of the displaced fluid. Always the upthrust will act vertically upwards at the center of mass of the displaced fluid. That is very important. We need to use that idea here. So it's a moment. We need to consider the principle of moments also. Clockwise moment equal to anti-clockwise moment. So it's an equilibrium. So this is actually a question which is related to principle of moments, Archimedes principle, and also conditions for equilibrium, right? So we are going to use all these ideas to answer this question now. Okay, so I drew the free body force diagram to show the forces acting on the rod. So I'm not showing any force acting at the pivot because I'm going to take moment about pivot. Okay, so you can see the dimensions I marked it. The uniform rod. The question says it's a uniform rod, so the total weight of the rod will act at the center of mass of the rod. That will be the center point. So total length is two-way. They are saying, the question is saying the total length of the rod is two-way. So the center of mass will be here from pivot at a distance A. So the length of the rod inside the liquid, we don't know, not given. So we take it as L. So the length of the rod inside the liquid is L, right? So the upthrust, where will it act? Archimedes principle, the upthrust is equal to weight of the displaced fluid. Where will it act? It will act at the center of mass of the displaced fluid. So what shape of fluid will be displaced? The shape of the fluid displaced is also a rod of length L. I hope you understood. The shape of the fluid or the shape of the liquid displaced is also a rod of length L. So where will it act, the upthrust? It will act at the center of that displaced length of fluid, that will be at L by 2 from the surface of the liquid at a distance of L by 2, because I took the length of the rod inside the liquid is L. So upthrust will act at L by 2 from the surface of the liquid. So this is the point where the upthrust is acting. I mark the upthrust capital U. So the distance of this point, the point of action of the upthrust from the surface here where the rod is touching the liquid, the starting point of touching the liquid, from that point, the distance of the upthrust point will be L by 2. Okay, so the liquid is at, the rod is at rest, at equilibrium. So now I need to find the cos theta. So according to this diagram, we know this height is h, this height is h. So what is the distance of the rod above or outside the liquid? That distance will be, how to find it? The total length is 2a. 2a, this is the total length. So the 2a minus L, 2a minus L is the length of the rod outside the liquid. So cos theta, if I consider this triangle if I consider, the right angle triangle. So I can say cos theta will be equal to, so I need to find the cos theta. So cos theta will be equal to opposite the adjacent h over this length. The total length is 2a. The length inside the liquid is L. So 2a minus L. That is cos theta. So the only thing I need to find L in terms of the given quantities. So if I find the L in terms of the given quantities, what are the given quantities? The given quantities are H, A or 2A. The density of the rod is given as sigma, and the density of the fluid is given, liquid is given as rho. So I need to find L in terms of these quantities. Then I can substitute here and find the cos theta. That will be the answer. Okay, so I need to find L. Okay, so we'll take moments. So you know it is at rest. Before starting moments, we need to find the forces acting on it. So anyway, I'm going to consider moment about the pivot, means I don't need to consider any force acting at the pivot, because you know when I take moment about pivot, that force will not included in the moment equation. So the forces acting on it are the weight. So I can say the weight could be written as mg equal to the length of the rod 2a. I can say it's a uniform rod. The question is saying, so the cross-section area, I can say capital A. So that will be the volume of the rod into density of the rod. Density of the rod is given as sigma. Density of the rod is given as rho. So rho. So that will be the mass. 2a is the length of the rod. A is the cross-sectional area. Rho is the density of the rod. So that is the total mass into G. That will be the weight of the rod. Okay, so what will be the upthrust? How to find the upthrust? You know, upthrust is equal to weight of the displaced fluid. That's Archimedes principle says. So here, how to find the weight of the displaced liquid here? The length of the liquid displaced is L. The cross-sectional area of the I already told that the shape of the liquid displaced is also a rod, which has cross-sectional area A. Is a uniform rod. So the shape of the liquid displaced also will be a rod of cross-sectional area A. So L into A, that's the volume of the liquid displaced, into its density sigma into G. So that is the weight of the displaced liquid. Okay, so I am going to take moment about the pivot. So I need to find the distances. Okay, so take moment about the pivot. About pivot, P, I named the pivot P. Okay, so mg, clockwise moment, mg times the distance, moments, a perpendicular distance to the line of action of the force. So the line of action of force is this one. Perpendicular distance from here is this distance I need to find. So in this right angle triangle, this is the center of mass of the rod, which is A. The distance from here is A. This is theta. So that will be A sine theta, mg into A sine theta. That will be clockwise direction. That must be equal to anti-clockwise moment, upthrust, times, I need to find the distance of line of action of the upthrust from the pivot. So the upthrust is acting along this line. This is the line of action of the upthrust. I need to find this distance. So from the pivot, I need to find this distance. How to find it? Okay, this length, how much is it? The total length is 2a. This is L by 2. So how can I find it? This is L by 2. So I need to find the length inside the liquid, the distance of the upthrust from the pivot. I need to find it. So the distance of the point where the upthrust is acting from the pivot is, this is 2a minus L by 2 is this length from pivot to this one. So U into 2a minus L by 2, that is this length. I need to find this length into sine theta. Okay, we'll substitute the values. For mg, I can substitute 2a rho g times a sine theta equal upthrust. I can substitute L a sigma j 2a minus L by 2 sine theta. You can see that. Okay, sine theta will get cancelled. G will get cancelled. Capital A will get cancelled. So you will get 2a. Here 2a. The A got cancelled. G got cancelled. So 2a into a, 2a squared. A into a, 2a squared. 2a squared rho, G got cancelled. 2a squared rho, sine theta also got cancelled, is equal to, so here A got cancelled, G got cancelled, sine theta got cancelled. So L into sigma into 2a. So 2a L sigma, 2a L sigma minus again L squared, L into L squared sigma by 2. L squared sigma by 2. Okay, so multiply the whole equation by 2. So 4a squared rho equal 4a sigma L minus L squared sigma. Okay, so I need to find L in terms of other quantities. You can see in this equation, A is a given quantity, rho is a given quantity, A is a given quantity, sigma is a given quantity, sigma is a given quantity. So L is the unknown value. So what length will be inside the liquid depends on the densities of the liquid and the density of the liquid and the material of the rod. So I need to find a real value for L. So it's a quadratic equation. So I can rearrange this one. I can bring it to the left side. I can say sigma L squared, bring it to the left, minus 4a sigma L plus 4a squared rho equal to 0. So I took it to the left, sigma L squared, then 4a sigma L plus 4a squared rho equal to 0. So this is a quadratic equation in terms of for the L squared. So you can say this is in the form of ax squared plus bx plus c equals 0. And we know the solution for that quadratic equation. If it is ax squared plus bx plus c equals 0 means the solution is, for this quadratic equation, x equal minus b plus or minus square root of b squared minus 4ac over 2a. To have a real solution without any complex numbers, imaginary numbers, b squared must be greater than 4ac. So here we compare it. So ax squared plus bx plus c format. So here I can say a is sigma, b is minus 4a sigma is the b, and c is 4a squared rho. So that's the way we can. So I can say L is equal to minus b means minus of 4a sigma. So 4a sigma minus b plus or minus square root of b squared. Square this one. The whole thing is taken as b minus in minus 4a sigma all this square is 16a squared sigma squared minus b plus or minus b squared minus 4ac. 4 into a sigma. 4 into sigma into the whole thing I need to find. So 4 sigma into 4a squared rho over minus b plus or b squared by 4a is 2a. 2a is 2 sigma. This is the solution. Okay, I can continue this equation further. Again, I'll write it here. L is equal to 4a sigma plus or minus square root of 16a squared sigma squared minus here 4 sigma 4a squared. So 4 into 4 16. So 16a squared sigma rho over 2 sigma. Okay, so 16a squared here, 16a squared. So I can take it out of the square root. So 16a squared, when it comes out of the square root, it will become 4a. So I can write 4a sigma plus or minus 4a square root of sigma squared minus sigma rho over 2 sigma. Okay, so here also you can see that here sigma squared is there. Here also sigma is there. Here also sigma, here also sigma. So I want to take the sigma squared out of the square root. If I take the sigma squared out of the square root, it will become sigma. So this I can write 4a sigma plus or minus 4a sigma. So I have taken sigma squared outside within square root 1 minus rho over sigma. So I have taken sigma squared out of the square root. So this will become 1 minus sigma over, rho over sigma. So I'm dividing here inside sigma squared over 2 sigma. Okay, so I can divide everything by 2 sigma. So if I divide by 2 sigma, it will become 2a plus or minus, again, 2a square root of 1 minus rho over sigma. That is the value of L. Okay, so which solution should I take? Plus or minus? Should I take both? Mathematically, both are acceptable. Here, you know that sigma must be greater than rho, right? Otherwise, this will become imaginary number. So sigma is greater than rho, right? Because otherwise, you can see that if the sigma is the density of the liquid, so if the density of the liquid is lower than density of the rod, what will happen? The rod won't float like this. The rod would have come to the vertical position because here the pivot has no friction. So if there's no friction and the density of the material of the rod is greater than density of the liquid, what will happen? The upthrust will be lower than the weight of the rod inside the liquid. So the rod won't be like this. It won't float like this. It will come to vertical position. By having a connection with the pivot, the rod will appear vertically with this side. But that is not happening. The rod is floating, right? So rod is making an angle theta, means the density of the liquid is greater than density of the material of the rod. Okay, so I found the final length. Mathematically, both are acceptable. Sigma is greater than rho, so this is a real number. Mathematically, 2a plus or minus 2a square root of 1 minus rho over sigma is correct. But now in terms of physics, the length of the rod inside the liquid cannot be greater than 2a. Because the total length of the rod is 2a. So it cannot be greater than 2a. So the only solution is I should accept 2a minus 2a square root of 1 minus rho over sigma, because if I take plus, the L will become greater than 2a, so it is not possible. Okay, so I have got it. So now I need to find 2a minus L. So 2a minus L, 2a minus L I need to find. Then only I can substitute in this equation to find the cos theta. How much is 2a minus L? L I know that. So 2a minus this quantity. So 2a minus 2a square root of 1 minus rho over sigma. So that will become 2a, 2a will get cancelled, minus into minus plus, it will become 2a square root of 1 minus rho over sigma. Okay, so cos theta, I'm using this equation, what I explained, the first equation, h over 2a minus l, that is in this right angle triangle, cos theta equal the length of this one above the liquid divided by h. So 2a minus l, I found it. H is this one, cos theta is this over this. So h over 2a square root of 1 minus rho over sigma. This I can write mathematically. I'll raise this side somewhere. Yes, I'll raise this part now. I'll keep it there. So I can write h over 2a cos theta equal to h over 2a times 1 over square root of 1 minus rho over sigma. That is cos theta. So finally, theta, you need to find it in terms of cos inverse. So the final answer, I'll write it here. So you got the answer now. So cos theta equal h over 2a, 1 over square root of 1 minus rho over sigma. So the final answer will be theta equal, I'll write this one in terms of cos inverse, theta equal cos inverse h over 2a into 1 over square root of 1 minus rho over sigma. Or you can write this rho can go up. So it will become square root of the whole thing. I can write, that's simple. This, 1 over this one, square root, I can keep it like this. Inside the square root, rho sigma minus rho. So it will be, you can see that the take the square root up, so the rho will go up. Rho over inside the square root, sigma over sigma minus rho. That's the final answer.